In addition to requiring greater glass quality, the tempered glass industry is constantly seeking new ways to decrease cost throughout the entire value chain. One of the most efficient ways to reduce costs is to use as thin glass as possible. Until today, the standard minimum thickness for tempered glass has been 3 mm. Now, Glastonere offers a welcome change for glass processors, as they are now able to meet the increasing demand of lower weight end uses that require thinner glass. This demand is already seen in the architectural, insulated glass, solar and appliance sectors. In addition to lower weight glass, the demand for thin glass is driven by a variety of factors, such as using less raw material and decreasing freight costs, just to name a few. In order to temper glass, glass needs to be heated over the transition temperature, which with glass is over 600 centigrades. After heating the glass, glass is rapidly cooled. This process leaves a residual stress inside the glass, which makes the glass tempered. Now, the thinner the glass, the faster and more powerful the surface cooling must occur. This results in the need for excessively high and costly cooling power, as the required quenching pressure grows exponentially when glass gets thinner than 3 mm. With traditional tempering technology, tempering thinner than 3 mm has been practically impossible. Therefore, the real key to thin glass tempering is to increase the glass temperature when the glass exits the furnace. This makes it possible to keep the quenching power at a reasonable level and still maintain the required cooling effect to the surface of the glass. With traditional roller heat technology, this has not been possible, since the rollers would cause quality defects if the glass would be heated to a higher temperature. Thanks to the unique air flotation technology, Glastonere eliminates the rollers from the process and allows the glass to be heated to a higher temperature without any quality defects. And thanks to the higher exit temperature, also higher surface compression levels can be reached as well. In fact, Glastonere tempers 2 mm glass to norms comparable with 3 mm EN standard, including fragmentation for safety. Glastonere is able to temper 2 mm glass with a surface stress of 120 megapascals, thereby providing the thinnest, fully tempered safety glass in the market. And the best part is, with Glastonere, the thinner the glass, the more energy is saved. It is actually the same exponentially growing phenomenon of energy need as I just mentioned, but in the opposite sense totally. Since the glass can be heated to a higher temperature than in the traditional tempering process, the energy need in the quenching phase is significantly lower. With 3 mm tempered glass, for example, a conventional roller type furnace requires twice the cooling power than Glastonere.